All right, we go. Next one, number 26. Just like the last problem, not a lot of room, so we're going to do it down here at the bottom. And this one is a couple techniques put together, and let's figure out how we know that. So it says find the mass of S8, sulfur, if the volume is 200. So they want to know mass. And the volume here is 2.47 liters. The temperature, and it says sulfur dioxide. That's different than sulfur. The temperature is 15 degrees C. Add 273 to that. So 273 plus 15 is 288. And we have a pressure, 110 kPa. Kilopascals from the reaction below. So they want to know this, and they gave us this. So this is a gas. It says so in the problem. It doesn't say in the problem. Well, anyway, this is our gas. It's talking about all the different gas temperatures. And sulfur is not a gas. So this is going to be a gas stoichiometry problem, where what we need is to solve for N. So that way we can plug in the moles of the sulfur dioxide to figure out the moles of the sulfur. So for that we need PV equals nRT, the ideal gas law. Now for a lot of students they say, well, we're also missing R. Remember, R is the ideal gas constant. There are 3 different R's mainly. There's a 4th one if we want to talk about PSI. But R is the ideal conditions. So we have the 1 atmosphere, the 22.4 liters, the 1 mole of gas at 273 Kelvin, and that's where you get the different R values. Now at 1 atmosphere, we've got 0.0821, and at kPa, we have 8.31. So what we're going to use is the 8.31 kPa liters Kelvin moles. That is our R value. And see, now we can easily solve for N. N is going to be pressure volume over R times temperature. I just divided both sides by RT, and that gets them isolated. Our pressure is going to be 110.4 kilopascals. Our volume is going to be 2.47 liters. We're going to do this over R, which is 8.31 kPa liters Kelvin moles. It's very important in an ideal gas law problem that all the units match R. So if this was milliliters, we had to turn into liters. And then finally our temperature of 288 Kelvin. So now this one's again tricky because when we put it in our calculator, we want to make sure that all those numbers are put correctly and the order of operations doesn't get messed up. Oops, 0.47. So there's the top, and now we're going to divide that by the bottom, 8.31 times 288, in parentheses like that. And so what this gives us is 1.14, you can just round that to 0.114 moles of sulfur dioxide. Now we got to go from moles of sulfur dioxide to moles of sulfur. So now we can do the stoichiometry part. Sulfur dioxide is 8. So 8 moles of sulfur dioxide to every 1 mole of sulfur. And now it wants mass, so we have to do the conversion from moles to mass. For every 1 mole of sulfur, there is the molar mass of sulfur, which is 2.1, and there's 8 of them. So that is 256.8 grams, S8. So now we take the answer, our 0.114, and we're going to divide it by 8. And then we're going to multiply it by 256.8. And so that gives us 3.7 grams of S8. Gas stoichiometry using the ideal gas law.